Double power supply part 4. In this video a lot of problems. I tried to make the double power supply with 2 wall transformers, and they were in fact very good, or not very good, but say usable. And I tried to use a more expensive transformer of 12 volt, but it gave the same results, and these results are especially the ripple on the positive and negative of that power supply. So I found a solution, and I want to work further on that, and when everything is okay I will publish it on YouTube. But here you can see the problems that I met. At first I made a Darlington of a BD139 and a 2N3055, but the problem was that that Darlington amplified too much. So it also amplified the ripple that is present at the end of the bridge rectifier and sent that into the N transistor. And I found that only the use of an N transistor here, this one, the the 2N3055, was enough to reduce the ripple and the hum at the output of the power supply. And I had to know that earlier when we study voltage supplies for very low voltages, say 5 volts, 3 volts, 6 volts, and it has to be hum free, ripple free. There's always a capacitor in the range of 10,000 microfarad. For instance, in the past with TTL circuits, 5 volt professional TTL circuits were always made with a good quality transformer and a 10,000 microfarad smoothing capacitor. And here we have in fact the same situation, but now for 12 volts. The capacitors are here, there are 2 of them, and there's also one here. So we have 3 of them as a smoothing capacitor at the output of the bridge rectifier, so approximately 10,000 microfarad. And here is the hum suppressor, and that hum suppressor is made with a 2N3055, only with one 2N3055, and a 3300 microfarad capacitor at the base. Of course, this looks very sloppy, and it is of course purely experimental anyway. Here is the output voltage now when I load the circuit with a 12 volt 20 watt automotive lamp. Let's listen to the hum that's present. I have connected here to the output of that not a Darlington, but only one transistor. At the output a signal tracer. I published it earlier on my channel, and we're gonna listen to the hum that's present at the output of the power supply. That's also always a very good idea. Use the signal tracer, connect it between the positive and the negative of your power supply, and listen via a good quality speaker, not via such a tiny speaker, whether you hear hum or ripple or whatever signals. on the output of your power supply. And also connect the scope. I have connected the scope here, and I've set the scope to the most sensitive situation. That's 2 millivolts here. And of course that means that we have here a very tiny ripple in the range of 2 millivolts or 5 millivolts or whatever. But in audio it's always very important that you listen to your power supply. So let's listen to the power supply with the help of that signal generator. And I hope it's a very fierce amplification of the output, and I hope that you can hear the hum now. And the hum also, the hum, and I mean the ripple, the hum also depends on the load. Especially when we have here the maximum load, that's a 12 volt lamp, 21 watts. There will be an enormous current flowing in the circuit, and these 2 capacitors, in fact that are 3 capacitors, together 10,000 microfarad, are not able to remove the hum completely anyway. But when there is a lower output current, the hum will go down. And I hope that you can hear that. And as far as I can see, it is a very tiny drop of hum. So here we have a low load at the output. Here we have a high load at the output. So you can see the differences. They are not very big, and that's in a certain way good. But you can hear the hum. And let's see what happens when we amplify via that signal tracer the output level, the hum, to its maximum. Of course, in many situations, in the normal situations, you will never connect a signal tracer to the output of a voltage supply, but it is this is an oscillation, but it is very good to do that, to see whether your voltage supply is able to supply real hi-fi circuits. Preamplifiers, for instance, need an absolute pure DC voltage supply, and chip amplifiers, often inside that chip amplifier there is a kind of hum, there's a kind of circuit that presses the hum down. Anyway, it is of course a problem. For pure hi-fi you need a power supply that's completely free of hum. Anyway, now we have the maximum load here. The voltage is, say, 8 volts. So when we go to a load that's not so big for this circuit, the voltage goes up to, say, 11 volts. And when we wait up to, say, 12 volts or so. And in fact that's a quite good result. when we watch all these lamps light up at 12 volt, and let's listen to the hum now, the hum level, the ripple level. This is an oscillation, but that's not, in fact, not very high. So it's a very usable circuit, even with a wall transformer. I want to publish it in, say, 1 week or 2 weeks. I want to get more hum depression. I want to push the hum much better down, but I'm almost sure I will not succeed anyway. In that case, I will publish the circuit as it is. So here is that one and only 2N3055 that does the job, and I have used a way to drive the base of that 2N3055 with current. And that current is limited here with the help of this 510 ohms resistor. And here we have that capacitor of 3300 microfarad that goes directly to the base to press the hum down out of the rectifier. And I first tried to do that with a Darlington, but that didn't work very properly. Anyway, best thing here in this case that has to do with the low voltage and the high current that I want at the output is to use only one transistor, and that transistor has to have an amplification factor of, say, 70 or 80. That's absolutely necessary to get a good hum, to press the hum very substantially down, the ripple very substantially down. Anyway, looks a kind of spaghetti, but I'm going to work further on it, and I want to publish the circuit. I think within 2 weeks. I need more time to get out of this circuit the best of it, using these cheap wall transformers that you can find everywhere, on flea markets, even on the scrap heap, etc. And with these simple components, cheap components, try to get a good result. The ripple again on the scope. It's now on 2 millivolts, so perhaps it's 2 millivolts. Perhaps I'm overacting somewhat by asking that a signal tracer, a sensitive preamplifier, picks up the ripple, but anyway, I think it's a good approach, especially for audio circuits.